Okay, so I'll start. I'm going to talk about the Symfony2 CMF framework. And so this is the website, CMF, Symfony.com. We have a bunch of slides, which is actually our main form of documentation at the moment. But I'm probably not going to show any slides. We've shown slides in the past about our core architecture and things like that. And I was talking to Konstantin on Thursday before the conference, and we actually showed KMP Labs, our storage architecture and all these things in January. And the end result of that demonstration was that they were scared. They were like, whoa, this is really complex. And in a way, what we're doing underneath of the CMF, it's fairly complex, very sophisticated. But as a matter of fact, most developers do not have to deal with any of that complexity. That is the beauty of what we're trying to do with the CMF. We're going to offer you lots of really powerful functionality, but actually the API you're going to use is actually what most people are familiar with Doctrine. So if you know Doctrine ORM, if you know MongoDB ODM, that is the type of layer you're going to be dealing with for the most part. And on top of that, we have some more things to make your life easier. So in that sense, what I'm actually going to go, I'm not going to come from the bottom and show you, all the low-level architecture. I'm going to show you what we have on top, and then I'm slowly going to go further down, showing what we have. And since I'm not going to use any slides, I can be very flexible. So if anybody wants to influence this talk in a specific direction, you can do so by raising your hand or screaming wildly. So this is me. My name is Lukas Smith. That's my blog. That's me on Twitter. That's the company I work for. And I just briefly want to talk about what Leap has done for this project. So 2 years ago, Leap organized a meeting in Zurich where we invited lots of Symfony2 core developers. At that point, there weren't that many. Remember, Symfony2 2 years ago wasn't quite stable yet. And we invited all of them to Zurich. We invited some of the competitors. For example, we had somebody from Typo3 come in. We had somebody come in from the Java community, and we discussed what we want to do. We came up with a plan of a storage API that we wanted to implement. Everybody said, great. And then Leap did it. For 2 years, we worked on this. Just from my gut feeling, I think we probably invested 2 man-years. We're a development agency, so we're not building a product that we want to sell to people. We just felt that it was very important to have something in the community, in the open source community, available to build customized CMS solutions that we want to use. And then it's totally fine if other people use it as well. So I assume many of you attended Larry's talk just before, right? And so he was talking about how Drupal is adopting Symfony2 components and things like that. So you might be wondering, why are we still bothering with, trying to come up with our own stuff? And in a way, we're actually sort of a tech demo for what Drupal is doing. So Drupal needs dynamic routing. We have built dynamic routing on top of the Symfony2 routing system, and they're going to use it. There are actually other content management systems that are also looking to adopt Symfony2, and they will also be using the CMF routing system. The storage layer that we're using is called PHP-CR, and there are other content management systems looking into adopting that as well. One of them is actually Drupal. How soon that will happen, we don't know yet, probably not for Drupal 8. However, maybe even in Drupal 8 it will be possible to replace their storage API with a module using what we've done. So let's have a look at this sample website. It's up on GitHub. You can check it out. It's like you have to run like 4 or 5 or 6 commands on the command line to install and run this. And then you have something like this. Now, let's play around with this. So we have a starting page. And the first thing I should note is that everything here comes out of the storage layer, that PHP-CR, which also Henry mentioned in his earlier talk. And we're building this website here entirely dynamic, which means that the routing comes straight out of the database. This menu you see here on the left-hand side comes straight out of the database. This content element here comes out of the database. These additional blocks come out of the database. And interestingly enough, you can edit them. right, inline, like this, right? It's stored right away. So if we reload this, then it will be persisted. The other thing we see up here in the corner up here is we can select the language here, so we can switch to French. And we'll see, some pieces are translated, some pieces are not translated. You see the same thing in the menu here. The interesting thing is that none of the UI code that is displaying this has anything to do with internationalization. This is all happening on the storage layer automatically. Because the content has been translated in the backend, when we fetch the page and we select the language up here, we update the locale in Symfony 2. We have a listener that hooks into that locale, and that automatically configures our storage API to fetch the content in the language we want. Now, as I mentioned before, not all pieces are translated, and that's because not all pieces were in fact translated in the backend. And so we have a rule system that you can configure based on how to fall back to other languages. So in this case, it's configured to fall back from French to English, and if English is not available either, it's going to fall back to German. And again, no code on the UI level at all about internationalization. Actually, the only thing I should say that has anything to do is this here, the little selector at the top to actually know which languages to offer. That's it. Now, we can construct a page with this tool, or with this architecture. As you can see here, this is actually one section, and these are blocks. This is using the Sonata block bundle. And let's have a look at how this looks on the admin interface. So the admin interface is something where we still need to do a lot of work. What we currently have is the Sonata admin bundle with some custom widgets. And I'm going to briefly show you a little bit how that looks in here. So we have a tree structure, and this is one of the key features of PHP-CR. Instead of having a flat structure of tables like in an ORM or having multiple collections like in MongoDB, we actually allow you to organize your content very similar to a file system. And in fact, this implementation that I'm currently using is called Jackrabbit, which is a Java implementation of this standard. You can even access it via WebDAV. So I could open up this tree structure in my browser on my files, on my operating system, just by mounting a WebDAV drive. Now, here we have different pieces of content, and here you can see this translation stuff. So we have this node, content static home, and we have these children, ENFRDE. And how that works is that if we fetch content static home, it will also fetch the given language that you're currently using and automatically figure out the object that's going to return to you will have the properties already in the given language. And obviously we can click on content here and modify it. So the other thing I want to show here, and that's something that, in my opinion, is quite revolutionary, and it's something that you will not find in any content management system, at least that I have come across, regardless which programming language. And that is, we have really cleanly separated the content from the menu structure and the routing system. What that means is, nowadays we're looking at, not just publishing to desktop, not just publishing to web, but we're actually publishing to lots of different output formats. Now, the problem is that most content management systems, they started off with just being a desktop solution. So, they have an admin interface, you can enter content there, and then they came, we also need to support mobile. So they have some flags there saying, okay, this is content we only display for desktop, this is what we do for mobile, and this is sort of the routing system. We've separated this really cleanly. The idea being that you organize the content in the way that the content authors need it to be, so that it remains meaningful to them. So they just organize the content. Then, in a second step, you can organize your routing structure, again using this tree structure, but what you're in fact doing is you're referencing nodes in that content tree over there. Now what that means is if you're doing a website, English, German, French, and you want to have a different routing structure for mobile, tablet, desktop, and so on and so forth, and of course all the permutations of all these languages, that's possible. You can have a totally different structured website for each language, each output format, driven from the same content tree. The same thing is possible with the menu. So again, there you have the flexibility of separating that. Now, that sounds very sophisticated, and yes, it is. However, it's not mandatory. Alternatively, we've also implemented a solution that allows you to do all of that at once. So instead of having the separation of content, routing, and menu, you can automatically drive all of that from one tree structure. So it's an option that you have if you have these sort of needs, if you have a multilingual website with different output formats supported and with different structures. But when you do this, it's much a cleaner separation. Let's briefly talk about why such clean architectures make sense. Now, I imagine all of you have heard about Varnish and how you can accelerate your website with that. Now, one of the tricky things about Varnish or caching in general is how to invalidate the cache. And most of the time, what we end up doing with the CMS, we're just going to give it like a lifetime of a couple minutes. The problem with that is that if something gets updated, you have to wait those couple minutes. Now, the other option, what you can do is you can do active invalidation, right? And active invalidation is great. However, the problem is you don't know where each node in your content repository is actually being used on the website. Like you might have a page where you're using, but that page might be referenced in other places and you're reusing that title, right? Now, wouldn't it be cool if you can have a solution that automatically figures out wherever that content is and invalidates that when you do any change? And you don't even have to code that into every admin tool. So by having a clean architecture, you can implement this very, very cleanly without having the logic attached to your admin interface. It's actually a very cool thing that Thomas Rabé has already implemented for the ORM to some degree in the cache bundle, which actually tracks the IDs that were used in creating the content and then stores that in Varnish so you can do invalidation. And the idea is that as soon as you modify the content, there is a general purpose listener looking for changes that then triggers off the invalidation. I'm not going to go into detail anymore further, but what I wanted to point out is if you have one piece of content for all your different output formats, and you always keep adding a new field for the different output formats to be able to serve that as well, you just have one blob. Right? And if you do any change, even if it doesn't relate to that, to all output formats, you're going to trigger the entire invalidation, or you have to have some custom logic that always figures out which part of the changes is actually relevant to the invalidation. By having this cleanly separated, you have the opportunity to also do clean cache invalidation, because you can just look at what has changed. If the content has changed, if it's used in the mobile, you can then regenerate that cache. Rather than putting everything in one gigantic blob and then having some custom logic always having to figure out how invalidation works. So let me go back to the site. Back. All right, let's just go here. Okay. So I just wanted to look at one more feature that we have, or actually two more features. So I mentioned here we have these blocks. And as you can see, some of them are editable and some are not. That's because some of them are actually driven from dynamic content out of the database, and others are actually hard-coded action somewhere in Symfony 2. And whenever you're creating a block, whenever you're doing routing, you can always point it to content or you can point it to an action. And whenever you do that, you can also customize what template to use and things like that. Now, the interesting thing with the block is here, we see this block right here, right? And I'm going to add some exclamation marks there. And let's go to company, where we're also using this block, right? And you can see here, the content that I modified on the home page is also visible here. So that's the core building blocks you need to do a CMS and to build content up from snippets. We're still missing a UI for this, but it's not rocket science to do this. The last thing I want to show is sort of, it takes me off a little bit on a tangent, but I want to show that we're looking at other cool stuff that is happening in the CMS world. So there's a project called Apache Stanball, which is about annotating or automatically tagging content just by basically you're training a database and then you can tag text based on that. So if we go back here, oopsie, no, I want to be here, right? And let's replace this piece of content here with some information about the Dallas Mavericks. Now I've chosen this content because the demo server we are hooking up to is actually trained to know about NBA teams. They basically took Wikipedia content and trained it. Now, what we have here is, with this integration here, is that these automatically figures out what this content is about and offers tags for it. So I can easily add those tags. So New York Knicks is showing up because the text actually talks about the New York Knicks somewhere here, right? So this is actually a solution that we just integrated into the CMF because we felt this is a value add that you're not going to find in most other CMS solutions. And it actually wasn't that complicated to add. Now, if we, you can already see that if I remove that content, then if you look at the suggestions again, then it's, obviously it's gone. Yes? Well, we don't have, basically this would then be persisted with the content, and then you could leverage that on, for whatever you feel it makes sense. For example, this solution could also be used for, you're going to author your content, and for example, now for the Dallas Mavericks, if we would still have that content in there, you want to add some pictures, right, that are relevant to the Dallas Mavericks, and you want to leverage Google to find them for you. So, you use the suggestion tags, you can automatically pick out which tags are relevant, and then based on that, you can go out and fetch images that are relevant to this on Google. Okay, so let's go, let me think what I'm going to show you next. Okay, so this is a slide deck. So actually I'm going to show slides. Where we sort of explain a little bit the big picture in all of this. And so this is the mission statement of the CMF project. As you can see here, we're trying to build sort of the infrastructure you need to build your own CMS. In the same way, kind of like Fabien built the components to enable you to build your own CMS if you need to, your own framework. And the goal being, we're not trying to head-on compete with Drupal or Typo3 or any of these, because they have a lot of UI features that are very generic, and they work quite well. What we're looking for is to provide tools for people that need to create a content management solution that is not standard, that is not generic, and therefore, there's very little benefit for them to using Drupal or Typo3. That being said, they still need to have some way persisting and building up content management data, and that's what we're offering them. And we're building on top of that lots of bundles to also make that more easy. So for example, KNP menu bundle, we have integration with PHPCR so that you can easily drive your menus out of that. We have integration with Doctrine ORM, again, to make it easy for Symfony2 developers to come on board and use all of this. And in terms of goals, what we're trying to do is we're trying to build a scalable solution with a higher level of usability, and we also want to offer documentation and testing. Now let me dwell on those 4 points. So in terms of scalability, thanks to using PHPCR underneath, it means that you can choose which implementation you want to use of PHPCR. There are multiple. So there's one, Jackrabbit, which I mentioned before, which is basically capable of handling a cluster of nodes with 100 gigabytes of data, and it can scale up to that. Now, not everybody is doing a content management system with 100 gigabytes in data, and in fact, some people are on shared hosts where they couldn't install a Java solution at all. So we're also working on an implementation that uses Doctrine DBL to just straight persist to a relational database. And then as a third option, more performant than the Doctrine DBL solution, there's a C implementation that was written by the Midgard project that also implements the storage API. So let me quickly show you, let me go back here. So this sandbox that I just showed you, last week, we created, or actually 2 weeks ago, no, it was actually a couple more weeks ago, at PHP Day, we had a hack night for the CMF, and there was somebody that hasn't used the CMF at all yet and created a bunch of functional tests for us. And we finally managed to merge them in last week, I think. And then earlier this week, Henry sat down and said, if this works with Jackrabbit, it should work with Midgard as well. So he did that, and all he had to do was add some configuration. There was no application business logic that needed to be changed in order to run the same functional tests with Midgard implementation. And then a couple days ago, I also did the same for Doctrine DBL. So what you see here on the Travis CI website is we're running those tests, those functional tests against the Jackrabbit implementation, against the Midgard implementation using SQLite, against another Midgard implementation using MySQL, and then finally Doctrine DBL, all against PHP 5.3 and 5.4, again, without any changes in the business logic. So this means, by this separation, you write your business logic once, and depending on the availability of server resources and the requirements in terms of data, you pick the implementation that best meets those requirements. And most importantly, if you have some special requirements that none of these solutions meet, they all happen to be open source. So you can fork them and customize them to meet your very specific requirements. But again, your business logic and the business logic of other people that have built apps on top of this infrastructure does not need to be changed at all. So that's what we mean with scalability. Now, with usability, what we mean is that most content management systems build their APIs ad hoc. There's one guy that says, wouldn't it be great to do full text search? Another guy that says, wouldn't it be great to have versioning? Another guy says, oh, this is all not performing, let's add some caching somewhere, right? And that's essentially what most of these content management systems look like in the end. They look like a mess of ad hoc inventions of things. And of course, any good project will then eventually refactor some of that, but they will have legacy code, and so people will be complaining, don't refactor everything out and whatever. So it remains quite messy. And the end result is that if you want to offer all these features like versioning, like a tree structure, like ACLs inside your database, then you will likely have a fairly messy API, unless you actually sit down once and you come up with a clean API. And we didn't just do that on our own. We actually adopted the Java content repository specification, and these guys have actually worked on this for 10 years already, right? So we took all of what they did, their experience, we looked at what PHP has to offer, and we made it work together. So where the Java guys obviously have, value objects because they're a strongly typed language, we have arrays and things like that. Also, if you're working with binary data, we are using PHP streams, so we're fetching the binary data when you actually use it. So we're really trying to integrate tightly into PHP, but the API you get is consistent and well thought out. So that's what we mean with usability, at least on a storage API level. On the front end, we're leveraging Create.js quite significantly. And there again, I think it's a very huge opportunity what we see there. Because similar to how we have a clean storage API with PHP-CR, we want the same for the UI. Because in the future, we don't want to just let desktop users author content. We want people on their mobile device, on their tablets, on their TVs to author content. And with that, you cannot offer a generic admin interface. It's just not going to be a great usability experience. You want to have a clean API between your UI and your business logic that allows you to innovate on the UI level and change and adapt things so that they meet the requirements of the given project. So that's what we mean with usability. Now with documentation, we failed so far to some extent. We definitely need to improve there. Like I mentioned, we have a bunch of slide decks that explain the philosophy. Some of the bundles are okay-ish documented. We need to improve there. And that's definitely a focus that we have for the coming months. Finally, testing. Especially the storage API is very, very well tested. And that's only the only reasons why we could actually enable the testing for the different storage implementations and have it work, because we actually have tests to ensure that they are compatible with each other. So if we look on Travis CI, let's briefly pull this up. Jackalope is one implementation. So if you look at this here, again, the tests run on Travis CI. And so this is the tests we're running there. So as you can see, we have over 1,000 tests that are running to ensure compliance between the different implementations. As you can see, there's a couple skip tests and a couple incompletes, so that's work to do. But that is what we think about testing. It's absolutely critical. I'm not sure how I'm doing on time. I still have plenty. Okay, great. So the other thing, since we're offering a framework, we want to allow people to use features at will. Again, the Drupal guys, they're going to use our routing system. In the beginning, they're probably not going to use PHPCR, but we are offering them these tools to use at will. So even if you decide you don't want to use everything we're doing, just pick and choose what you think you need and go with that. And we're totally happy with that. So if you look at a normal Symfony 2 request, it sort of goes through that router, dispatches to controller, and generates a response. And I just wanted to elaborate a little bit on how the routing system works. So as I showed earlier, we're driving the routing entirely from the database. And basically, we've done two things to make that happen. So we created what is called a dynamic router, which can do a dynamic lookup in a database, because the standard Symfony 2 router can only do a static lookup. So we created that. However, we still imagine that you will have static routes because you have static actions that you want to use and things like that. Also, of course, the dynamic router, due to its dynamic nature, will not be as performant as what you have with a static router. And so we created something additional, which is called the chain router. And the idea there is that you can actually chain multiple routers after another. So you can, for example, have first the standard Symfony 2 static router, and then second the dynamic router. So any route that points to a static action you have in your static router, and then if there's no match, it falls back to the dynamic router automatically. In theory, you could also say, I have a couple static dynamic pages in the content management system, and I will never delete them, and I want them to be really fast in terms of lookup time. Then you can also move those to the static router, and then even to Apache by using the dump command to get Apache mod rewrite rules. Now, if we do have the dynamic router, then we essentially fetch the content out of the database. So we already have a model. So we actually put that into the request objects in the attributes, so that in the controller we have this data available as well. This is sort of cut off. But here I just wanted to, again, elaborate a little bit on the architecture. So we have that wiggly line up there. That's sort of the separation between the browser or the UI and the business logic. So that's, you know, standard Symfony 2 stuff with some added bundles. And the interesting thing, since we're doing Symfony 2, it means that you can use any Symfony 2 bundle and add it in there and leverage it as part of your CMF. So for example, for detecting the locale based on the browser preferences and cookie and things like that, we're looking into a standard Symfony 2 bundle called Lunatic's Locale to use that. And any other bundle, imagine, you can put in there. If you want to do authentication with Facebook, you just use the FOSS Facebook bundle, and you can easily add that into your business logic. And then underneath, you have your storage API, PHPCR, and then in between, we have PHPCR ODM. And let me switch to the PHP-CR ODM slide deck to just show you a little bit about how the ODM works. So who here has used Doctrine ORM or Doctrine MongoDB ODM? So that's most of you. So most of you should be very familiar with what I'm going to show you, except you're going to notice that everything you need to do for a content management system is going to be easier. So in a way, if you compare the architecture a little bit, so up here you have the client userland code, you have a Doctrine2 document manager or entity manager, you have some database library, some protocol, you're talking to a database. And at the bottom, you have sort of what we have to offer. It looks, in terms of architecture, very similar. However, you have some additional APIs you can use, like versioning or tree traversal. So instead of just having to be able to run queries, you can actually just traverse your tree structure. So you can say, I'm starting off at a root node, and then I'm seeing what children I have, and then I can find the children of those children and things like that. Skip over that. Skip over that. So this should look very familiar. In this case, we're using annotations to map out the document. We support various annotations here. First thing you see with public ID on line 9. So we're using the ID annotation. And here, we discussed this quite a bit. So what this ID here is actually not an integer ID. It's also not a UUID. This is actually a path. We decided to label it ID because we felt that many people coming from the ORM and world will be more familiar if we call it an ID, but in fact it's a path. We do, however, also support UUIDs, so you could also just map out UUID and then you get a universal identifier, which is very useful if you want to, for example, migrate content from a staging environment to production, because you have the same identifier in both systems in the end. Another mapping that you can use is parent document. That basically just gives you an instance of the parent node name. So if you're in a path, basically the path is constructed from the node name and the parent path. So that's just mapping that. And then you can map any other properties like text here is a string. You can have binary content. You can have Boolean, state, and things like that. And all of them can even be multi-valued. So you can have multiple binaries, multiple strings associated, like you could have for tags, for example. Then we have the standard API. You just find stuff. So here in this example, we're finding the parent. We're setting a node name. We're setting some text. We're registering the document with the document manager, and we're flushing. Instead of doing that step where we assign a parent and a node name, we could have also just set the ID or the full path on the ID property. And then we can fetch that content again, manipulate it, store it, we can remove it, and things like that. Let me show you some more mappings. So for example, imagine we have a page and we also always want a logo. With that mapping, we define that there's a child, and that child has the node name, the logo. And on that, you just assign another document instance, that contains an image or something like that. You can also have a collection of children. And actually, what we're doing here, if you look at line 12, we're applying a filter. So actually, that collection of children will only show children that have a node name that starts with the letter A. And then finally, down here, you see we have references. We have reference one and reference many. So this is what we're actually using in the routing system. So if you have reference one and you assign, for example, a content document there, then it's not going to create a child object, but instead it's going to reference the UUID of that content document. Yes, there's a unit of work. Yes, well, in theory. Transaction support is optional in PHP-CR, but we do wrap it in a transaction if transaction support is enabled. But we don't have features like the special counters, like to do like a read with a write automatically and things like that. Yes, so basically, well, it's implementation specific, how you, what kind of work you do. So in theory, it's the job of the PHP-CR implementation to then decide if it's going to send the entire document or just exactly what you changed. And then finally at the bottom we see referrers. So this is actually a collection of every document that has a reference to this document. And I mean, if you just think about it a little bit, especially with children, but also with references, you have so much power that is so easy to use in order to structure your content in a way that makes sense. Versioning, basically we have two different types of versioning, simple versioning and full versioning. Simple versioning is just a linear history. Full versioning basically gives you branching and tagging. So you can just, get the linear version history, reset it, and then restore that previous version. You can delete previous versions if you want to clean up your version history. What's interesting here is that, so here with this checkpoint, that's actually, so deciding when you're persisting, if something should be a new version or not, is something that you can choose. So many of the ORM solutions for versioning, basically, they always create a new version when you write. It automates that. In PHP-CR, you can choose when you want to create a new version. So for a minor edit, for a minor typo, you're not creating a new version, and therefore you can keep your version history a lot cleaner. Furthermore, we have a full-text query API. That query API also has some functions dedicated to operating on a tree structure. So you can say, I want to match everything that is underneath this parent, and things like that. And in fact, PHP-CR is a NoSQL database in the sense that it's schema-less. So this will not explode just because you're matching the from matches node that doesn't have a text property. If it doesn't have the text property, that's just considered to be null. And as you can see here, you can set limits and offsets and things like that. We also have a query builder, so you don't have to construct a string. You can actually build the query. We do have transaction support, so again, a flush would do an automatic transaction if available, but you can also manually create a transaction to wrap multiple flushes. And finally, we have translation, so we have native translation support. So by mapping translator equal to attribute, we're defining that we want this document is translatable, and we're defining a strategy which is called attribute. So when I was showing you the sandbox, we saw that there were child nodes for the translations. That's the strategy children. There's the other strategy attribute. What it does is it actually stores the translated values in the original document, just namespacing them accordingly. Now, you can map your properties as you need, and then for any that are translatable, you add translated equal to true, and then you can do something like this. So here we're creating an article instance. We're assigning a property to a French text. We're persisting that document and we're calling bind translation. What that does is that PHP-CR ODM will now track the translated version properties and will keep in mind that this is the French version. Then you can change the assignment and then bind that the new version of the state of the object to English. Alternative, instead of calling bind translation, you can also modify the locale, which is also mapped to be a special property you see up there. It's a locale. And now, when you flush that, it's actually going to flush all these 3 different language versions into the database. Now, when you want to work with that content, you can do find translation and then explicitly say which language you want. But remember, we also have a listener, so if you don't pass in a locale, it will use whatever locale you currently have in your session. So yeah, so we have different strategies, and actually you can define your own strategies if you want. Let's skip over that. So as far as I know, that will be responsibility of the given implementation. However, you can extend that and you can add things. So for example, the Doctrine DBL implementation comes with a repository schema class, and you could modify that if you feel you want to change that. And again, that's the exciting thing. You have this power to hook into that. So for example, PHPCR supports different node types. And the Doctrine DBL implementation by default stores all the nodes regardless of node type in a single table. Now, if for some reason you say, usually I do not interact with different node types at the same time, it's always one after one or the other, you can in theory also modify the implementation to spread that out over multiple tables to improve performance. And then you can add custom indexing and things like that. So the PHPCR ODM stuff is, and the PHPCR and all of that, especially running on top of Jackrabbit, is production ready. It works, it's well tested. We still have to do some things. For example, XML and YAML mapping support is currently lagging behind. We want to add some more of the ORM features, but we have most of the key ones. We're still missing logging and result caching. So that concludes PHPCR ODM. Now, I think actually I wanted to hear some questions now. So first up, does it still sound like rocket science to everybody? Can you raise your hand if you're still concerned about the complexity? Not that many hands. I'm not sure if you're worried to say the truth to my face, but I think I don't know if you saw, there was a blog post on Symfony.com that was published this week about the CMF, and we're about to release our first alpha version. And there was a little screencast in there done by Freddie, and I met him at Confu earlier this year. I think he didn't have time to attend my PHPCR talk, but we chatted a little bit, and I just told him, the CMF is going to be great. So 3 weeks ago, he approached me and saying, I have a new CMS project ahead of me where I need to do a custom solution, and I want to try out the CMF. So it ended up that I think for 2 weeks, we almost had nightly 1 to 2 hour Q&A sessions. And the end result is that screencast that he published, where he basically created UI editing to create new sub-pages. You could you manage versioning of those pages. He created a custom solution to optionally map pages for different languages so that he could automate switching to these when the user changes the language. I think the screencast doesn't show it, but he actually also has reordering of the pages. So all he has to do is, if he has a child collection, all he has to do is change the order of the child pages in memory, persist, and then we will automatically update that. So do check out that screencast, and it really highlights the power that the CMF already offers to a CMF or Symfony 2 developer that doesn't need to know anything about PHPCR that's going on underneath, and what he can do within a 2 or 3 week time frame.